Hey guys, today we're looking at our last set of notes for Chapter 8, 8.5, Day 2, all about finding zeros. So, hopping right into box number 1 with some definitions. A zero of a function is just the x value that makes the function equivalent to 0. So that's why we call them zeros. They're an x value that makes my function 0. They are synonymous with roots, with x-intercepts, all those other things we've been looking at so far this chapter, where we've solved the equation, we have them set equal to 0. The zeros of a function are the same thing as the x-intercepts. Which means, if we're trying to find a 0, we're just going to substitute 0 in for that y value and then solve for x, just like we did yesterday in 8.5 day 1. In the kind of the tail end of box number 1, we said, hey, what are the x-intercepts of this function? We just replaced 0 in there for my y value and then solve for x. Same idea, it's just calling it a different name. So if I'm asked to find the zeros of this function, the only difference here is that it's f of x instead of y. In box 2, find the zeros. So I'm going to just start by replacing f of x with 0. X minus 1 times x plus 2 equals 0. Now we can just use zero product property to set each of those two parentheses equal to 0. So x minus 1 equals 0, and x plus 2 equals 0. So then I add 1 on both sides to get positive 1. I subtract 2 on both sides to get negative 2. And those are my two solutions. Depending on how they phrase it, you could leave it like that. If they want it as coordinates, then 1, 0 and negative 2, 0 would be those two coordinates. All right, so that's finding zeros. Not anything different, just a different name. In box 3, now we're looking at something that's a higher level polynomial. So not something you necessarily have to graph, but we still can find my zeros of a higher degree polynomial. Now this is something we spent an entire chapter on in Algebra 2, but for right now, we can look at it just simply as making sure everything is factored out. Any of my factors, x minus some number of a polynomial, tells us that that number that was subtracted is a factor. Now we don't have to necessarily understand that whole premise. We're still going to find zeros the same way. I'm still going to start by replacing my function notation, in this case h of x, with 0. That gives me x minus 1 times x squared minus 16 equals 0. So now before I can use zero product property to solve, I have to have everything factored out as far as I can. And that second parenthesis can actually be factored one step further. So I'm going to start with that. That is my difference of two squares shortcut, right? X squared minus 16 factors out into x plus 4, x minus 4. Because negative 4 times 4 is negative 16, negative 4 plus 4 is 0. Or you can remember it as your difference of two squares shortcut. Right, we only have a binomial, two terms to factor out. It's a GCF and or the difference of two squares. Those are only two methods we know how to factor a binomial. Now that it's factored completely, I can just set each of my parentheses equal to 0 to get my zeros. So x minus 1 equals 0, x plus 4 equals 0, x minus 4 equals 0. So we get pretty quickly that my x-intercepts, or my zeros, are positive 1, negative 4, oops, not a parenthesis, negative 4, and then positive 4. My hand can write separate from what my brain is thinking about. There we go. So those are my three zeros, my three roots. Okay. And again, don't let it throw you off that there's more than two solutions. We have that when we get to higher degree polynomials. We have three factors, we have three solutions, no big deal. Still the same process. Our last box here, box number 4, is all about finding roots or finding zeros. Again, those are synonymous with each other, but now it's given a graph. So we're not given an equation that we're asked to solve. We're given the picture of our graph and asked to find the zeros, or in this case, find the roots, which you hope and pray that there's lots of these on the test because they are so super simple. All we have to see, or all that you have to remember, is the fact that roots and zeros are the same as x-intercepts. So my graph here has an x-intercept here and here at negative 1, 0, and 3, 0. So without having to do any extra calculations or anything, you know that the solutions to this equation, my zeros, my roots, would be -1 and +3, because that's the two spots where it crosses the x-axis. And that's it. That's all you have to do for finding your roots. So that's all I got for you. Nice quick lesson for our last one for 8.5 day 2. The homework is down there at the bottom. It's page 455, 21 to 36 all, so both evens and odds. As always, if you guys have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.